Okay, welcome back. This is lesson 4 for group 1, which is about percentage of increase and decrease. This lesson is a little bit more challenging, so do try to pay attention. And of course, if you get confused, you can always go back and replay the parts that you're not understanding and write questions in the comment section, and I will get back with you as soon as I see them. Okay, but let's get going here. With the opening exercise. So it says Cassandra likes jewelry. She has 5 rings in her jewelry box. So in the box, sketch Cassandra's 5 rings. Not looking for anything artistic, just go ahead and make really quick 5 different rings. And I'll do that on my side paper. And then when you're ready, we'll continue, okay? Okay, so you should basically just have like 5 circles for this. It's not that big a deal, just other than a visual representation. Okay, so for the next part, it says draw a double line diagram relating the number of rings as a percent of the whole set of the rings. Okay, so looking at basically something like this, we have 2 lines that are horizontal, the top line and the bottom line, and then we have the number of rings 0, 1, 2, 3, 4, and 5. Okay, so as in terms of a percent of the whole set, if you have 0 rings, that is going to be 0% of the collection. And of course, if you have 5 rings, that would be 100% of the collection. So your job for the next part is to figure out, so what about the rest of them? If you have 1 ring, 2 rings, 3 rings, 4 rings, so on, what percentage of the collection do you have? So go ahead, fill that out, and then when you're finished, continue the video. Okay, so hopefully you didn't have too much trouble with that. So in this collection, we have 5 rings. So as a percentage out of 100, you just divide the 100% by the 5 rings, and that'll give you a percentage of 20% per ring. So then go back to your double line graph. So 1 ring would be 20%, 2 would be 40, and so on until you get to 5 rings, which is 100%, which is what we said to begin with. Okay, nothing too difficult so far. All right, so some questions basically that we've kind of already hinted at. What percent is represented by the whole collection of rings? What percent of the collection does each ring represent? So go ahead and answer that one really quickly and then resume when you're ready. Okay, so we already talked about, well, the whole collection would be 100%. It's the whole thing. And then for 1 ring, according to the table that we just made, 1 ring would be 20%. So let's say you lost one of the rings. You had 5 rings, you lost one. You would have lost 20% of your collection, and you still have 80% remaining. Okay, pretty straightforward with that. All right, so for the first example type problem, going back over here, it says Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? Okay, so if we think about what we just said, she has 5 rings and each ring represents 20%. So if she gets another ring, so then she'll have 6, the percentage of increase will go up by 1 ring. It'll go up by 20%, because 1 ring, as we said just earlier with the last problem, is 20%. Okay, so the amount of increase is equal to the value of that item in the collection. Okay, that makes sense. So because there's 5 different rings and each ring represents 20%, we said 1 ring is 20%, 2 is 40, and so on, that an additional rings is going to increase her collection by 20%. Okay. All right, so on to some exercises. I do a little bit of work here. There's a lot more coming. So it says John increased his trading card collection by 5. He originally had 15 cards. What is the percent increase? Use the equation quantity equals percent times whole, which is the same formula that we've been using to arrive at your answer. Then justify your answer using a numeric or visual model. Don't necessarily need to do that. Visual model. Okay, so it says we have 5 cards. He originally has 15. What is the percent of increase? So if we have 15 cards, what percent is 5 of 15? Right, so go ahead and write your formula out and do your substitutions, and then we'll continue when you are ready. Okay, so once again, we use our whole times percentage equals the fraction. In this case, the whole would be his whole collection, which is 15. That's how many cards he has. Okay, and then the part that we are, okay, so that's not correct. The part that we're trying to figure out the percentage of 15 is the 5 cards that he's adding. So this actually is going to be a pretty simple problem. Working it out algebraically, go ahead and find your answer and then resume this video. Okay, so let's talk about the algebra first, then we'll talk about working it out. All right, so we have 15 times p equals 5, which means we need to divide by 15 on both sides. Now, in the fraction over here, the division problem that we're going to be working, we have 5 divided by 15. But both of those numbers, we can reduce those. So if we're going to divide 15 into 5, we can divide both by 5. Or you could just kind of mentally do this, because it's pretty simple, and see that 5 over 15 is 1/3. And so 1/3 is 33%. So we could pretty much finish the problem at that point. If you are not comfortable with doing that, you could just simply do this division, which is 15 into 5. Bottom number divides into the top, 15 into 5. So got the problem worked out over here. You get the exact same thing. You get 0.33, repeating decimal. It'll keep going forever. So we just stop and say it's 33 1/3, or 33% would be perfectly fine for this answer. Okay, so that means that for John, if he gets 5 more cards, that'll increase his collection by 33%, which is what the question's asking for. Okay, so the next question goes off of this one. So it says, suppose instead of increasing the collection by 5 cards, John increased his 15-card collection by just 1 card. Will the percent increase be the same as when Cassandra increased her ring collection by 1? So if you remember, we got 1 new ring. Cassandra had an increase of 20%. So go ahead and substitute for that problem, and then when you're ready, resume the video. Okay, so to answer the questions, we basically do the exact same problem. And so whole times percentage equals the fraction or part. The only difference is that the fraction is 1 now and not 5. So we work through the problem. 15 times p equals 1. It means we have to divide both sides by 15 to get rid of times 15. Did the work over here really quickly. So 15 divides into 1.00. I had to add the decimal, add to have the zeros. So as we're working percentage, you're going to have a lot of decimal answers. So you get the answer of 0.066. We move the decimal 2 spots to the right when we're making a percentage. So when we make the percentages to the right, when we want to make a decimal, we go to the left. And we end up with 6.6%. So to answer the question asks, is the percentage the same as when Cassandra added 1 ring? And the answer to that is no. when we added one ring for Cassandra, one ring was 20%. But when we add one card, it's 6.6%. So question number C, letter C, says, based on your answers to part B, how is displaying change as a percent useful? Well, a percentage will tell you based on the number that you have. So if you have a large collection of something, or you have a large group, in adding one more thing will be less of a percentage. It would just be like if we had a test with like 50 questions. If you get one of those questions wrong, you only got 2% off, because each question would be worth 2 for 100%. So if we have 50 questions, it's 2. Now, if we do a different test, let's say there are only 10 questions. So there's a smaller collection of questions. Each question is worth 10%. So if you miss one question on a 10-question quiz or test, you're already down to 90%. Whereas if you have 50 questions, you miss one question, you still have 98. So the bigger the collection, the less of an increase by adding just one. Okay? So let's keep going. Okay, so it just says a sales representative is taking 10% off your bill as an apology for any inconveniences. Okay, so it's really difficult to have a one-person discussion, but just know that if the person's taking 10% off of your bill, that's not what you're going to pay. 10% off, just like we were working with group 2 with the fractions. Now we're just doing basically the exact same thing with percentages. So 10% off means that you are going to pay 90%. If we took the whole, so let's do that on some paper over here really quickly. So let's say, just to make it simple, that your bill was $100. Okay? And you got 10% off your bill. So multiply it by 0.1, which is 10%, move the decimal 2 places. So this is going to equal $10. That's not what you're going to pay. This here is your discount. This is how much you're going to get off your bill. That is not how much you're going to pay. If you want to figure out how much you're going to have to pay, then you take the $100, which we had over here, and we would multiply it by 0.9 or 90%, because that's what, if you get a 10% discount on your bill, 90% is what you're going to have to pay. So 10% or $10 discount means, obviously, the simple numbers, $90 is what you're going to pay after you get your discount. So this is something that's going to come up when we're doing the problems. Make sure you're paying attention to what the numbers say. Just like if we had a percentage of, let's say, there's a box of crayons, and we say 20% of those crayons are red. If we multiply the number of crayons by 20%, we'll get the amount of red crayons. That would make sense. 20% red crayons, we multiply by the whole, we get how many red crayons we have. If we wanted to figure out how many are not red, well, if 20% are red out of 100%, all the rest of them, they're either red or they're not. That's the only two options for this problem. So then 80%. So 80% times the total would give us how many are not red. So you just kind of go back and forth with the percentages a little bit. Okay, let's go on with the problems because we have a few of them coming up. Okay, so this is a lot of words, but it's not that difficult. So as Ken said, he is going to reduce the number of calories that he eats during the day. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by no more than 7%? Okay, so For this problem, we basically want to figure out what percent of 2,500 is 2,200, and then from there, we can figure out if he did that. Or if you wanted to, you simply could figure out what 7% of 2,500 would be, what amount that is, and then figure out with his 2,200 calories how much of a decrease he had. So we'll do this two different ways so you can see either one would work out just fine. Let's start with, you could do your substitutions and then write your formula out and then continue the video and we'll talk about both. Okay, so for this problem, let's talk about the multiplication method we talked about first, and then we'll do the equation. Again, either one of those would get you a good answer. So if we're going to use the percentage, which is 7%, we multiply 2,500. That's his normal calorie intake, and he wants to reduce it by 7%. So what would 7% of that be? So all we have to do is multiply 2,500 by a 7%, which is 0.07. Always remember, you need to move your decimal twice. Do not just simply write down 0.7 or think you know what it is. Write down 7%, move the decimal 2 places, add a 0 where you need it. In this case, you would need 1, and then do that. So if we multiply it by 0.07, as you can see over there, we get 245.00, or 245. Now we subtract that away from our total. So we have 2,500, we subtract 245, and we get 2,255, which should be how many calories he should have at the least, because he doesn't want him to go below 7%. Well, his calorie intake when he went back was 2,200. So that's below 7%. So in that case, he took, or his percentage is greater than 7%, because this would have been 7%. A decrease of 7% would mean he's at 2,255. His increase was greater because he is at 2,200 calories. So he is more than 7%. Okay? The other method is to use the formula. If you want to know what percent of 2,500 is 2,200. Okay, so set this up in a simple equation. Whole equals part. We have 2,200 equals what percent of 2,500. So we just work it out, divide by 2,500 both sides, and we get 0.88, or 88%, which would be a decrease of 12%. So that is too much. We wanted 7%. He had a decrease of 12. That's not good. So that's not what the doctor suggested. Okay, so let's keep going. There we go. All right, so this problem actually is kind of simple. So it says, Skylar is answering the following math problem. The value of an investment decreased by 10%. The original amount of the investment was $75. What is the current value of the investment? So it says Skylar said 10% of $75 is $7.50, which makes sense. To multiply it by 0.1, you're just going to move the decimal over one spot. And since the investment decreased by that amount, you have to subtract $7.50 from $75 to arrive at $67.50. It says create one algebraic equation that can be used to arrive at the final answer of $67.50. Solve the equation to prove it results in the answer of $67.50. be prepared to explain your thoughts, blah, blah, blah. Okay, so for this problem, we're talking about these amounts of decreases. I'm going to show you two different ways to do this really quickly. These will be used a lot as we go on, so try to pay attention. So for this, we have to figure out what do we have. We have, in this problem, we have the original amount, and then we have the drop or the decrease, and from that we get or equals the new total. Okay, so how to do this? So the original amount is $75. Okay, that's pretty straightforward. Now, how to get this decrease? Now, obviously, we want to subtract the decrease to get this amount. So we could do this two different ways. The first one I'm going to show you using subtraction. The second way, I will show you how to use this in a multiplication problem and to get the answer basically in just one step. Okay, so for this one, to get the decrease, how do we get the amount of decrease from the number we're given? So we would do that. Obviously, we know that the number we're looking at is $7.50, but how would you do that in a single equation? How would you get that number? So we would have $75, and we would put minus, and then $75 again, times our 10%. And then that would equal our $67.50. So we'll kind of work this out really quickly. All right, so order of operation, we would do this 10% first. So 75 times 0.1 or 0.10, same thing. So then you would end up with $75 minus $7.50 equals $67.50. So we subtract the $7.50 from $75. You do the math if you wish to off to the side, but you will get $67.50, which is what we want, equals $67.50. All right, so that's the longer version, and you want to use that. That's always fine. Just have to remember, just like when we were doing those problems with the ages of people, where it says some person's age, you would use X minus X plus 4 or something like that. Somebody, Bob, and Bob's sister. Bob is 4 years older than his sister, but we don't know the ages. We would put Bob as X and his sister as X plus 4 because she's 4 years older. We add these together, and then they would have to give you the sum. We're basically doing the same thing, where we have to use the total twice. Once as the total, and the second time to get the amount of the decrease. Okay, so now I'm going to show you really quickly how you can avoid doing that if you pay attention. So we just talked about is the amount of decrease is 10%. So the stock market's value went down by 10%. So we could go ahead and multiply by that, but if it decreases by 10%, what's left of the original percentage of the investment? So we had $75, 10% is gone, that's the amount of the decrease, so what's left? Go ahead and write your equation for that percentage. So we know $75, and if we multiply it by the percentage we have left, in one step, rather than having to do all this up here, we should be able to get to the answer in just one step. Okay, so pause this and write this out, and then we'll work this out, and then the rest of the work is just using this. Okay, so hopefully you knew that if we had a decrease of 10%, that means that 90% is still there, or So if we multiply $75 by 0.9, we should get $67.50, but let's try it out so we can prove it. Always remember, you never multiply by percentage. You have to change it into a decimal first. So this would be $75 times a 0.9. Don't need that extra zero. Screw it off to the side. Let's just work that out. So 75. Then this extra zeros past the decimal don't really do anything either. So we can just skip those. Not to worry about that. All right. So I'm going to work out the problem. 9 times 5 is 45. Carry the 4. 9 times 7 is 63. Plus 4 is 67. Okay. We have one decimal place. So we move it here. And so we have 67.5. This is money, so we have to add a second decimal place for the cent, and we get the exact same thing. So up here, we get the 10%, the amount of the decrease. So the percentage of the decrease, we multiply it by the whole times percentage of decrease gives us the amount of decrease, and then we have to subtract it. But a shorter version is, instead of multiplying it by the percentage of the decrease up here, let's multiply it by percentage that's left. If we multiply it by the percentage that is left, we'll get the amount that's left. So that just skips and saves a whole lot of extra work. Okay, so multiply it out, and we went ahead and got the same exact answer. Okay, I believe there's a couple extra questions on this section, so... Okay, so it says, Skylar wants to show the proportional relationship between the dollar value of the original investment, X, and the value after a 10% decrease, Y. He creates a table of values shown. Does it model the relationship? So he wants X to be the original investment and Y, what is left after the 10% decrease. So let's take a look at what it says. It says, okay, $75 and Y is 7.5. Now remember what he's after. He's after what is left in the account after the 10% discount. So we just did the first problem. Is that correct? If we have $75 and we take 10% away, will we end up with $7.50? So hopefully you knew, basically because we already just did this problem, that if we take 10% away, we should end up with $67.50. So the Y in this case is not how much it's left, it's the amount of the discount. So this is an incorrect table because this is not, at least for what he wanted. If he wanted Y to show the amount of the decrease, then sure, this would be perfectly fine, but that's not what he said. He said he wanted it to show what is left in the account after the 10%, so this is not correct. Okay, let's move on. I believe there's about 3 more problems left, and then we'll get to the assignment. Okay, so it says Justin earned 8 badges in Scouts as of the Master Scouts last report. Justin wants to complete 2 more badges so that he will have a total of 10 badges earned before the Scoutmaster's next report. Okay, so it says, if Justin completes the 2 badges, what will be the percentage of increase in the badges? Okay, so he currently has 8 badges. So this goes back to the problem we were doing before. If he has 8 badges, that's what percent, each badge is what percentage. So you might want to do that using your formula. Whole times part equals, or I'm sorry, whole times percentage equals the part or fraction, and find out each individual badge is what percentage of the total collection. Okay, so with this problem, I did it 2 different ways again. So the first one, I figured out what was the value of one of those badges. So if we have 1 badge and the total collection is 8, 8 times P, the whole is 8, times what percentage equals 1, divide by 8 on both sides. You can do the division on the side and you get 0.125. So each badge is worth 12.5% of the total. I also did it using, instead of 1, I did it with 2. This would get us to the actual answer to this problem, which is 8 times p equals 2. Okay, so what percentage of 8 is 2? Divide by 8 on both sides, you get 1/4 or a quarter, which is 0.25, so 25%. All right, so that would make sense because 2 badges would be 25, 4 badges would be half, 50%, so it does make sense. Okay, so let's go on with the example B. It says express 10 badges as a percent of 8 badges. Okay, so same general thing, except this time the whole is 10. I'm sorry, the whole is still 8, but the part is 10. So we want to know what percent of 8 is 10. Okay, so go ahead and do your substitution, and you can work this problem out to the end, and then resume the video. Okay, so go ahead, use your formula. The whole is 8. That was the whole collection. And we have a percentage times p equals 10, because that's what we're trying to work with right now. So the increase of 2 badges. Do the work on off to the side, divide by 8 on both sides, and you should get 1.25. You're dividing a smaller number, 8, into 10, so you're going to have over 100%. So we have 125%. Okay, so 10 would be, or 10 badges would be 125% of what he has, which would make sense. If we had 100% of his collection, he would have 8. So 125% would be an increase of 25. That's basically what they're going or working at. Okay, let's look at number 4. So this one says the population of cats in a rural neighborhood has declined in the past by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on cats. Current cat population in the neighborhood is estimated to be 12. Approximately how many cats were there originally? Okay, so for this one, you're going to use your formula. I will warn you again with this one, there is a trap in this problem. So go ahead and write your formula and then substitute, but don't go any further. Continue the video and we'll discuss why some of you probably used the wrong number. Okay, so if you read through the problems and wrote your formula, this is probably what a lot of you have written. So this is whole times percentage equals the fraction or part. That's good. We're looking for the whole in this problem, looking for the W. Times 30% equals